All right, everyone. So what we're going to do now is begin our study on our last topic for all of PreCal, and that topic is the topic of limits and continuity. And what we're going to cover in this video is your 3 assignments for the week, all in one video. And what we're going to be covering is this standard right here, understanding the concept of a limit and estimating limits from graphs and tables, as well as finding one-sided limits. So your goal should be able to estimate limits from graphs today and find one-sided limits from graphs today. And so first, let's talk about what a limit is. It's a really abstract idea. It makes more sense once you start looking at some graphs, but a limit is the value a function approaches or intends to reach, I guess I should say, for a certain value of x, right? And so these are the 3 types of ways you'll see kind of a limit written generally. And so I'm going to verbally say these for you. The limit as x approaches c of f of x is a. The second one would be the limit as x approaches c from the right for f of x approaches or is a. And the limit as x approaches c from the left for f of x is a. So the idea is this is what we call the general limit. In other words, we need to investigate this from both sides. This one is what we call the right-sided limit. Right positive, usually on the x-axis. If you're positive, you're further to the right, so c from the right and c from the left. And the idea is, again, there's many different ways you can look at a limit. And so I'm actually going to start off with one-sided limits because, in other words, a general limit like this doesn't exist unless these 2 limits agree. So we'll see what that means. We'll first look at one-sided limits. Right? Now, it might be a little small on your screen, but this says what appears to be the value of the limit as x approaches 3 from the right for f of x. So here, this line in this problem, you're not always going to see it like this, but here's the x value 3. And we want to know what the function is doing as it moves towards 3, but to the right of 3. And so here's what the function is to the right of 3. It's this blue path. And what the function is doing as it comes towards 3 from the right-hand side of 3 is it's actually going down forever. And there's actually a lot of different ways you can classify this, but a common way you'll classify this is either as you approach 3 from the right, the function approaches negative infinity, or you could say the function is unbounded, or you could say the limit does not exist, which you might remember that line from a certain movie. All right, and I'll go through another one. Different looking graph this time. They ask what appears to be the value of the limit as x approaches negative 3 from the left. So now I'm looking at negative 3. There's no vertical line. You have to think about it yourself. And you have to think what is left of negative 3. And it's this segment of the graph right here. So when you look at this segment to the left of 3, as you move towards negative 3, what is the function approaching? Well, it's approaching this open circle. And what is the value, the y value of this open circle? 6. And so that's it. The answer is 6. What is the function doing as it moves towards negative 3 from the left? It's getting closer and closer and closer to negative 6. But this open circle means it never actually gets to negative 6 or it never gets to 6 at negative 3. Kind of interesting. Maybe we'll just do one more to see a few of the different things you might see. All right. This one kind of looks similar to the first example we saw. What's the limit as we approach negative 1 from the left? Again, here's the line where x equals negative 1 is. If we're looking to the left of it, we're looking at this segment. And what is the graph doing as we approach negative 1 from the left? It's moving down forever, which again could be called negative infinity or does not exist or unbounded. All right, so that's the idea of one-sided limits. Figure out which side they're curious about. Again, in this case, I guess I'll do a fourth one. They're curious about 4 from the right. So the function has this segment going on to the right of 4. But as I approach 4 on this segment, I'm approaching the y value 5, so the limit would be 5. So it doesn't matter, the weird thing is in limits, it doesn't matter where the open circle or closed circle is, it matters what's going on with the path of the graph. Where is the curvy line moving towards? That's what a limit cares about, not the closed or open circle necessarily. All right, so that's one-sided limits. And now we'll be able to move a little bit more quickly. We'll do estimating limits from graphs. Now we're looking for general limits. And you can see that because there's no plus or minus here. And the idea is now you need to consider what's going on when you look at it from both sides. So if you want to approach negative 3 from the left-hand side, it's approaching this value right here, which is just a little bit below -5. When you approach -3 from the right-hand side, it's also moving towards this exact same point a little bit below -5. And so that means the limit does exist. In other words, both sides are moving towards the same point here. Again, don't worry about where the closed or open circle are. Worry about where the paths of the graph are moving towards. And they're both moving towards a little bit more negative than -5, which would be -5.3. All right, we'll do a few more. All right, up next, again, this time we're worried about the general limit. And so the limit as we approach x, or the limit as we approach -2, from the left, we would say it's a little bit more negative than -6. And the limit as we approach -2 from the right would be just about 5. And this time, here's the curious thing, the left-handed limit is essentially -6 almost. The right-handed limit is 5. Those don't agree, they don't go towards the same value, and that means the limit doesn't exist. So in order for the general limit, the one without a plus or minus sign, to exist, you need to make sure that both the left hand and right hand are essentially meeting up at the same place. So these two, when you read the left-handed limit, it says -6. When you read the right-handed limit, it says 5. That's not the same value, so the limit doesn't exist. We'll just look at one more. Up next, this time we're worried about the limit for g when we approach -1. And again, from the left of -1, you can see we're approaching this open circle a little bit above 3. From the right of -1, we're approaching the same open circle a little bit above 3. So in other words, the left and the right are going towards the same thing, which would essentially be a little bit more than 3. And that's it. So now we've got one more. I'm kind of going out of order. Now let's look at limits intro. So kind of the same idea. What's the limit as we approach -4? Again, the left and the right are not meeting together, so the limit doesn't exist. The limit as we approach 3, this time they are meeting. We're meeting at here and here. So from the left and from the right, we're essentially at -4. This time, from a table, let's see what's going on here. This would be approaching -2 from the left, technically, a little bit more negative. And you can see these values are getting closer and closer and closer to the value 8. And from the right-hand side, they're also getting closer and closer and closer to 8. And you can imagine that the further, or the more zeros you put here, or the more 9s you put at the end of here, the closer these would be to 8. So since they both are moving towards 8, the general limit is 8. Maybe we'll have one more table question. Nope. This time, what's the limit as we approach 0? Again, the left-hand limit is 5. The right-hand limit is -5. Since they don't agree perfectly, the limit does not exist. All right, maybe I'll just try to find one more table question really quick. All right, one more table question. You can see from the left of 1, you're approaching -6. From the right of 1, it looks like you're approaching something else, but again, if you were to round this would also round essentially to -6. So the left is approaching -6, the right is approaching -6, so the limit is -6. So far, all of our table limit questions have agreed and found an answer, but that doesn't have to always be true. All right, but anyways, that's the whole assignment for the week, those 3. The idea is, again, a limit is the value a function approaches or intends to reach. What that sentence really means is follow the curve of the function, not the points of the function at the value you're looking for. If you want to find the general limit, you actually need to compare the right-hand limit and the left-hand limit and make sure they both agree. It's totally possible for your left-hand and right-hand limit to not agree. Again, just look at this example right here. The left-hand limit is 6, the right-hand limit is -4. So those would be valid answers for the left and right, but since they don't agree,